Okay, this is the last day of exponent rules, and today we're doing exponent negative exponents and how to deal with negative exponents. So the way that we deal with negative exponents is that as an exponent is negative, it tells us that it's on the wrong side of the fraction. So the first thing you need to do is make a fraction if you don't have one. You may not need to make a fraction. And then 2, if you have a negative exponent, you move that term only to the other side of the fraction. So you can pretend like your fraction is a house. You have first floor and second floor. And exponents are only happy if they're positive. Otherwise, they have to move up. So for this first example where we have 2x squared over 3b to the negative fifth, this guy down here is not on the right floor. So we're going to go over the line and change the sign of the exponent. So it's going to become positive because it's where it's supposed to be, but the 3 stays in the denominator. So these can sometimes get a little bit complicated. You just have to take it little piece by little piece, just like all the other exponents that we've been working with. So in every one of these cases, I'm going to make a fraction first. And then what 9 to the negative 2 is telling us is that 9 is on the wrong side of the fraction. So I'm going to move it down. And when I switch it over the line, I change the sign of the exponent. So that's 9 squared. And if there's nothing in the top, it's a 1. And then, of course, 9 squared is 81. Remember, anything to the 0 power is 1. Just a review from yesterday and the day before. B to the negative third, that's B is in the wrong side of the fraction. So I made a fraction, and I'm going to take that negative exponent term and drop it to the other side. And if there's nothing on top of our fraction, we need to make it a 1. Last example on this page, m to the negative ninth, that guy is on the wrong side of the fraction. We're going to move him up. When we go over the fraction line, we change the sign of our exponent. And then you can just leave that as 7m to the ninth, or you can put a 1 on the bottom of the fraction. All right, now we're going to move to some more complicated examples. All of our exponents need to be positive. That's our goal. So that's just something to keep in mind as you're working through all of these problems. Take your take your guy, put a fraction in if you need it, and then move your terms around so that your exponents are all positive. So I'm going to put a 1 on the bottom here. I'm going to circle my 1 that is not where it should be, the guy with the negative, and I'm going to drop that down to the other side of the fraction. 5e to the third stays on top. B squared goes on the bottom. And that's your final answer. Everything's positive. We only have 1 of each base. So you're done. Again, with number 6, I'm going to circle the negative exponent. And I'm going to move that term, just that piece, to the other side of the fraction. So, on top of the fraction, I have x to the fifth. And I'm going to change the sign since I went over the fraction line. And you can put a 1 out front there. You can put a 1 underneath if you would like. Those 1s aren't necessary, but you can put them there to hold it. Again, if you're using this video to learn the concept, pause if you need to. Listen to the problem again. That absolutely is a great thing about using videos. You can always watch the problem happen again. You can always pause if it's too fast. You can work ahead if it's too slow and fast forward. Okay. Make a fraction if you don't have one. Circle the term with the negative exponent, and maybe even draw that little arrow to tell you where it needs to go. So the 4 is going to stay up top. The b is going to stay up top. The 1 is already underneath, and we need to move that c cubed to the bottom. And the to the third is going to become positive because we moved over the fraction line. Number 8, I'm going to circle my negative exponent. I'm going to move it to the other side of the fraction. And when I move it down there, my exponent is going to change sign. So it's negative, so it's going to become positive. The m squared was already down there. I'm going to move the n to the 5th and make the exponent positive. Now, if we're moving to the bottom of the fraction, you have to have the top of the fraction, you have to have that 1 at the placeholder. And that's fully simplified. All right, some equivalency problems. So which one is equivalent? Again, we've been really focusing with these problems because they are like what you're going to see on the OST. We've been really focusing on how many solutions you're looking for. On this example, since it says which, we're only looking for one. Only looking for one. So go ahead and pause the video, see if you can distribute that negative 3 ends and simplify. So this is putting all of our examples together. The first thing we do if we have an exponent on the outside of the parentheses is we bring it in, and it needs to become an exponent on everything that is in our parentheses. That means if there's no exponent there, like with the 2, then negative 3 becomes the exponent. If there is an exponent and you're bringing your exponent in, we multiply. So it's going to become negative 2 times negative 3. Remember, there are only 3 operations we do with exponents. Add, if we have the same base, and we're multiplying. Multiply, if we're doing power to a power, which this is, and subtract, if we're dividing. So simplify it for yourself and think, we only know 3 things to do with exponents. Which one of those 3 should we do? Okay, so I'm just going to do this multiplication first. I'm going to baby step. So 2 to the negative 3rd, and then negative 2 times negative 3 is 6. X to the 6th. And I'm going to make a fraction since I don't have a fraction yet. Now the next step I'm going to take is to deal with the negative exponent. So here's my negative exponent, and that means that term is living on the wrong side of the fraction. So my x to the 6th is going to stay up top, and my 2 to the 3rd is going to go to the bottom. Now, since I'm moving over the fraction line, I change the sign of my exponent. X to the 6th on top, 2 to the 3rd on the bottom. And then 2 to the 3rd, you can put that in Desmos or in your calculator. 2 to the 3rd is 8. That's the last thing we're doing here, is just putting that in our calculator. And x to the 6th stays as x to the 6th. And that is B. So since it said which, we're only looking for 1 there. Now, if it says select all that apply, we have lots of examples. We could be picking all of them. So you have to be really careful with this one. So what I like to do with these is do the main problem, the original problem, get it fully simplified, and then I do all of the other little baby problems. All of these problems down here we'll have to do as well that are not fully simplified to see if we come up with something that matches our simplified answer. So when I'm looking at this, I see 1, 2, 3, 4 problems that I'm going to have to do in one. So when you're working through the OST, they're not only testing if you know how to do exponent, they can test all of your exponentials in one problem like this. So it's not very kind, but it is efficient. So our first step is to group our like bases together. So I'm going to put the 4 and the 2 next to each other. I'm going to put my x terms next to each other. So x to the 9th and x to the negative 11. And I'm going to put my y terms next to each other, which they already were. Y to the 4th and y to the negative 3rd. And I like to mark them off like that. If you were doing this on the computer, you would definitely want to write the original problem down and then work it. The second thing I'm going to do here, I don't have any parentheses, so I'm going to multiply my bigs, add the littles. And that's super untechnical term for multiplying your coefficients, or the numbers out front, and adding your exponents. So 4 times 2 is 8. X to the 9 plus negative 11, x to the negative 2nd. 4 plus negative 3 is going to give us y to the 1st. And then our last step here is to deal with the negative exponent. So we have one negative exponent. That term needs to go to the denominator. So I'm going to need to make a fraction here. 8y is going to stay on top, and x squared is going to go to the bottom. So just 3 steps with that problem. That's pretty nasty. There's a lot going on. And that actually matches this last one right here. So that's fully simplified. So that's one of our answers with a flex. I'll just apply. If that's one of the answers, then this one in the middle cannot be. All right, now we're going to do the little baby problems here underneath and simplify these. Go ahead and pause and see if you can do them. All right, here we go. 32 divided by 4. So when we have a stacked fraction like this, and we're going to divide our bigs and subtract our littles. So that's how we're going to do this one and the one there by our first answer that we picked. So 32 divided by 4 is 8. And then we're going to subtract our exponent. So I'm just going to write that out. Y to the negative 2 minus negative 3. And x to the 5th minus 7. We're going to bring everything to the top of the fraction. And then if we have a negative, so we're going to just everything to the top. If we have a negative, we'll drop it to the bottom as our last step. So negative 2 minus negative 3 minus a negative is plus, so that's just going to be y to the 1st. 5 minus 7 is negative 2. And again, that's over 1. That's the top of our fraction. So that tells us that this x to the 2nd would need to go to the bottom. And that matches our answer over there. So this guy also. Moving right along. Let's do this 16 and 2 one, which is very similar. The one with this other fraction problem is very similar to the one we just did. Divide the bigs, subtract the little. Let's stay kind of on that flow. 16 divided by 2 is 8. And then be careful because your like bases aren't right on top of each other here. I have y to the 6 over y to the 6. So this is 6 minus 6. And then x to the 5th over x to the 3rd. So x to the 5 minus 3. 6 minus 6 is 0. 5 minus 3 is 2. That is not going to match. Not going to match my answer. But we had to do that math, especially when I did 16 divided by 2 is 8. It looks like it might work. Okay, last one. This 3 here, we need to deal with this 3 first. The 3 needs to come in and be an exponent on the 3 and the x. So 2 to the 3rd, x to the, and when we're doing power to a power, we multiply. Negative 3 times 3. I have this y here in the middle, and then x to the 7th out here. 2 to the 3rd, I would put that in my calculator and get 8. Negative 3 times 3 is negative 9. Y, x to the 7th. And now, if you can, just see these two exponents on your 7 or on your x's and know you need to add them. Negative 9 plus 7, that's going to be x to the negative 2nd. But don't also forget to bring down that y. And the last step is going to be always to make sure everything is on the right side of the fraction line. And this guy is not. If we bring that guy down there, we're going to match our original. I'm not going to lie, I totally agree with you. I know you're thinking that is a lot of work for something that looks like a multiple choice question. But that's how you get it right every time. There's really no shortcut. I wish there was. Alright, I'm going to go ahead and stop this recording and do a separate recording for the putting it all together problem on the back. And then you can work the practice.